G'day, Michael here. I have been frustrated by the printing process limiting my speed, and I've had difficulty with this print head, and also I've had difficulty getting the bond strength out of the materials I want. Anyhow, out of sheer frustration, I ended up taking to this extrusion tip with a 1mm drill bit. And boy, has that opened up a lot of possibilities. I'm so surprised at what I've managed to learn from getting this large tip. Now obviously the large tip leaves me exposed to things like dripping and so forth, but the other thing it does is also shows me the physical volume limit of what the hot end can melt. Stay focused, will you? So I don't know whether you can see this here, but a 1mm tip is giving very nice wide paths. Going through the slicer program, which I'll show in a second, but for the slicer program, I've actually set the volumetric limit. This is my first print using the volumetric limit as my speed guide for the parts. And I've got to say, that is one awesome feature, particularly for the larger tips. Because what I've found is that the this print head with this tip on it, like it's the 1mm hole, I cannot put through any more than 10 cubic millimeters per second and expect it to terminate at the ends of the extrusion and the beginning of the extrusion. The other thing, being such a large tip and being vulnerable to dripping and so forth, I've had to tweak the retraction and feeding on, refeeding on the beginning of a path. So when it moves, does a non-printing move, I've got it to feed an extra 2mm to initiate the print, and I've got it to retract 5mm to stop oozing between passes. So it's basically retracting 5 and adding 7. So and that seems to be producing pretty well gapless prints. Right now it's doing its first layer of unsupported like a top infill. I've found that it needs 4. I've done previous prints with just 2, but it doesn't quite fill in the large gaps on these 20% hexagons. Now you can see these hexagons are very, very large. I don't know whether you can understand how large these parts are. I'll just try and get it in a perspective where you might have a reference to something. There's my finger relative to it. I can't get too close. Maybe something else. Well, that disc is 65mm in diameter, so it's a fairly large part. Now, come on, focus you. Focus. Get there. Okay. I don't know whether you can see that, but the extrusion has terminated nicely to the edges and making an excellent bond strength. What I mean by an excellent bond strength, here I have one that was very last test that I made. Here's the back side, printing on the glass. I made a tweak. That was set to 120% as my first layer. I'll bump this up to what's on the printer right now is bumped up to 160%. I found 200 was just a bit too fat. Too big a spacing. But anyhow, what's incredible about this is the bond strength is, how can I say, it's stronger than a credit card. Now this is PLA, and I guess it's about the thickness of a credit card, so it gives you some sort of reference. But I'm getting extremely good bond strength, and PLA finishing with a nice glossy finish like that. Here's one of my little support wheels. That was done with a 200% first layer. And what I'm surprised with getting these temperatures right, I've got a glossy edge. Now here you can see underneath, this is actually 2 pieces stuck together. See if I can separate them. Focus. Now here you can see the 2 layers for the top aren't enough to cover that span, but considering those hexagons are about 8 or 10mm in size, that's actually spanned quite well. But the problem I noticed with the larger tip, focus, come on guys, focus. So see, find a spot. Oh, not so much this one, but the other one will show it better. It wasn't quite supplying a good enough, solid enough start to the top upper rings here. And that's why I've had to add the extra 2mm of feed on starting. Come on, focus. Okay, so you can see it's sort of, well, it's daggy and incomplete because it didn't quite get enough extruded to get started, so it was pulling and so forth. But you can see the whole print is really nice and glossy. Now you can see here my set temperatures, focus, my set temperatures are 193 degrees. If I go much higher than that, I start getting a boil happening and bubbling and carrying on with the PLA. And lower than that restricts my speed. So 193 seems to be the sweet spot for this print head with this 1mm tip. I run the platen at 80 degrees because it keeps the PLA in a nice relaxed state, and I think that's where I'm getting part of my strength. Now, I don't know whether you've been following me, or you've randomly come across this video. I'm making larger parts in the order of sort of 200mm cube, pretty much the maximum this printer will print. Now I want to do that in hours rather than days, and so that's why I've been bumping up the speed, finding every way I can to increase the speed. But also I need bond strength because I'm actually making real working parts, not just you know, ornaments. These are actually tools, parts of, well, like this case, the large part that I'm making will be dust extraction components, which I can't get the suitable fittings easily off the shelf somewhere, and I figured I could 3D print them if I could only get a decent print. Everyone else is looking for a pretty print, I'm looking for a reliable and tough print, and I'm just about there. We'll see when this part's finished how that works out. Oh, there you can see that daggy edge I was telling you about on that last couple of millimeters here. Now, those parts, this part goes into that part and forms the wheel. I'll just put that together. It's a bit cold here, hence my jacket. So I'm actually printing in a cold environment, which is surprising this morning. I've only got 16 degrees centigrade, which I don't know what that is in Fahrenheit. I guess you can look that up. Close look maybe, better lit maybe. Focus. No. So you can see how the print is nice and glossy. It's a beautiful print. So that 193 is obviously not harming the filament. It seems to be happy at that range with this particular filament, with this particular print head, and this particular tip. That just seems to be my, you know, my magic recipe. Okay, so I'll go over to Slicer. Focus. Okay. So there are my paths. It's quite a coarse set of paths because of the 1mm tip. But let's have a closer look. They're quite coarse. When you consider those discs are 65mm in diameter, that's pretty coarse. So if I go down through the layers, you can see the gaps are, you know, pretty big within the hexagon infill. But with this I'm able to test what I can get with a top fill, which I think my magic number is 4 in this case. The bottom's quite happy with 2 because it's supported by the glass, of course. It's just the upper layers have to span the hexagon. So I'll just go through that slowly again. See if I can do it gently. It's giving me 2 layers. Hang on. There's our first layer. Second. Third. And so on. So up it goes. There's not many layers of the infill. I'm just testing limits of the whole thing. Okay, so other layers. But these wall parts on this second part to the left hand side here, they're the ones that have not been printing completely, and that's why I had to add the extra 2mm of feed. Okay, so how do we do this? Might just reduce the size of this window so I can get on the camera. Okay, I'm trying to hold this steady with one hand and drive it with the other, so I hope I don't shake around too much. Bear with me. Okay, with Slicer I set it on expert settings, so this is how you drive it. Now here is the, well actually I'll start at the beginning. Because I've got a 1mm tip, I'll see if you can see that, 1mm tip, I've been going at 0.5mm in height. I seem to find roughly half the tip diameter seems to give the absolute best bond strength that I can get. I'm only using 2 perimeters because obviously it's a wide tip. I don't need, to get any extra thickness really out of it. And there you can see the 4 top layers and 2 bottom layers. I've got it to set some basic for quality and so forth. But the seam position I choose random so I don't get like I found in one of the ducts that I printed, it produced a fracture line straight up the whole ducting if it's aligned. So I've left it random, but that also leaves you a little bit exposed to stringing. So you've got to get your retraction and so forth pretty well tuned. Okay, next thing. Infill. This is actually sort of a crash test. I'm doing 20% infill with that large tip, leaves big hexagons. So there's a lot to span when it comes time to top fill. Okay. Anything else here? Nothing. Retract only when crossing perimeters. Well, that's a setting to try and keep the dagginess when you cross a perimeter. But if you're staying within a given print area, it doesn't matter if you get a bit of a dag inside a space. But if you're crossing outside a perimeter, it's important. Okay, skirt and brim. I'm not really using that. I've just got enough to get something printing through the print head. Support material I'm not using. Speed. Okay, I've set the thing for 80mm a second, which this printer is definitely not doing. But going down to the bottom, where are we? Yes, you can see the travel speed I've set at 130. It's probably doing that. But there are all my settings for the general print speed. Multiple extruders. Now you've got to watch out for this one. If you have this enabled, you can set it to, if you're using 2 different extruders, you can get it to drop the temperature while it's waiting around between prints. Okay, advanced. Here's the first layer, set to 160. That seems to work rather well with this tip combination. Okay, my wife lets me have breakfast. Output options. Okay, what have I got going here? Well, the filament has to be 1.75. Oh yes, there's my temperature set for the extruder and the base. Now I'm just looking for the one where we have, okay, on the printer settings on Slicer, general, nothing special there, extruder 1. Okay, offset, focus. Okay, the retraction length there is 2. Minimum travel after retraction 2. Extra length on restart 1. Okay, so an extra length on restart is 2. There we go. When tool is disabled for multiple extruder setups is 10. Okay, so there's the retraction settings. I had in my head slightly wrong. Okay, so there's I'll spend some time on that. Nozzle diameter 1mm. And there's my retraction settings for this. Okay. I think that's about all the settings. Let's see how this thing's progressing now. Okay, the layers are starting to bridge now. So we're on the 3rd layer. How does it look down here? Okay, yes, it's starting to bridge nicely rather than sagging. You can see the 2 layers isn't quite doing it. The 3rd layer has just about got it, and I think the 4th layer should give me a nice full top layer. We'll see how it goes. Won't be far off. Now, that may look like it's travelling slow, but it is pumping through 10 cubic millimeters a second. So it's quite a lot of material. For argument's sake, whoops, 0.2 mil diameter, a 0.4 millimeter diameter tip would take, what's that, around about 8 times as many passes to do the same job. So what looks like it's slow here is in fact a lot of volume being pumped through the printhead. And the robotics can certainly outperform the printhead's melt speed. So I'm getting the speed and volume out of the tip diameter, and considering I'm not making very small parts, it's not a problem. But I was able even to make a a press fit assembly for that, or this component. So the precision's obviously good enough. Okay, there's a spanning infill. Interesting. Okay, so it's, oops, focusing on thing. Okay, it's building up now, a bit further up. You can see it's done the 4 infill layers on the large part of the disc. Now it's moving on to the press fit part. This is obviously the inner part of that press fit. Within a layer or two have been completed here. But as you can see, like 1 or 2 layers is not enough to span those big hexagons. If I had a higher percentage infill, I could use less I could use less top and bottom fill, or top fill anyway. Okay, but you can see that 2 starts to fill it up, and obviously 3 and 4 brings it to a flat surface. You can see the flats there. Of course, with a bigger tip diameter, you end up with some gaps where there's, you know, a small portion to be filled. I'm waiting to see what this on the left is, the part that goes over the part on the right. So I'm waiting for that layer to come up of the 2, you know, sort of a double ring pass. I guess we'll just wait until it's done. Now, all the different types of paths are done with different thicknesses and widths and so forth. And so having that volumetric speed limit is actually quite a good thing. Unfortunately, I've got a small leak in that tip, which is a nuisance. But it's a reasonably painful disassembly, reassembly process to fix all that. So I'm just putting up the leak. It just produces an occasional dag, as you can see the dot. Whoops, laughing's no good. Alright, so okay, still another layer to go. See, the non-printing moves are actually quite fast. Also, you can see with these thicker extrusion with the bigger printhead, you can visually see what it's doing quite easily. With the naked eye, you can see it's building a thickness. Whereas when you're dealing with sort of 0.1 of a millimetre layer height, it's not quite so obvious what the tip's doing. So there's a lot you can learn out of these bigger tips. I've actually bought a range of large tips for the Delta, but I'm still waiting for one component for the printhead to turn up from China. Hope it turns up this week. I think I'll be applying a lot of these principles to the Delta because it seems to have a better ability to melt the filament. It's a better perspective perhaps. I think this might be the last layer on this part. You can see how the start was quite solid. Well, let's see if it makes a complete loop, because this is important. Yes, it did. And as I say, I'm after strength rather than prettiness. So function over form for me. So having those completed where the fill meets the outside perimeters, that has to be a good bond area, and as you can see they're quite a nice strong bond. got fairly minimal stringing between the paths. Focus. Okay, so now it's building. As you can see, the random starts means that the start and stop is at a different spot, which is very good. So we don't have a fault line in any one location. I'm hopeful that this might work. Okay, job done. Well, I'll let that cool and see how it looks later on. But so far so good. You can see every little perfection or imperfection in this job, but basically this circular part here seems to be nicely produced without gaps, which is far superior to the last ones I did. When that's cooled, I'll take it out and show you how it works. Okay, so I'm going to see if I can take this part off here now. It's cooled down. Oh yes, they break nicely free. All I have to do is let the platen cool down. Well, there's the back side of the print, and you can see that's quite beautiful. Some very, very minor imperfections there on that initial start. It's almost a full top surface. Probably acceptable for something structural. Now the big test is, are these press fits going to work? Oh yeah, focus. Sorry about the shakes, but I'm trying to hold this one hand. But you can see the beautiful glossy edge. It's nicely finished. The surface is good. The bond strength is great. Part again. That's the inner part. That's the outer part, and now that outer ring is much better done. I'll compare that to the early one. Let's put it on the floor. Okay. The early one had a bit of a daggy, incompletely printed top edge because it didn't start properly. It's important to initiate every extrusion properly. Once it's initiated, it'll continue. See how beautifully that's printed? Focus. That's just, well, I'm going to use the word perfect. That's not really a good word, but that's certainly all I'll get out of a 1mm tip. The material is good, the print is incredibly fast. With a 0.4mm tip, I was flat out getting this done in 2.5 hours. Whereas this was, you know, much quicker. Of course, you haven't seen the whole print time, but yeah, that's quite an acceptable print. But the most important thing is where the infills bond to the outer perimeters is nicely bonded, and you can really see that it's sort of nicely squished into those parts. There's a lot of strength there. It feels strong too, like wish I could impart the feel of this. Actually, just the sound of it maybe. They sound very they just sound solid. If you have more of a dead sound in the part, you know the bond strength's not very good. But also the fact that this stuff's glossy means the plastic itself is in very good condition. And of course, the flatness of the print. Let's just have a look down the flatness. Can we do that? It's beautifully flat. So having the platen at that elevated 80 degrees to keep the PLA relaxed means the parts stay flat. And it stayed bonded to the glass until I cooled the glass down. Then it just basically comes loose by itself. So I don't know about you, but I'm very happy with that result. That's about all I can wring out of this video. Yeah, feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.